numbers. So we're going to look at numbers. We run through numbers and see how we can exhaustivate this chapter on numbers. Okay, so without much ado, let's begin. We have what we call natural numbers, natural counting numbers. So when we say natural counting numbers, we start counting 1, 2, 3, 4, 5, 6, till as much as we can, right? So we start counting numbers. So if we include the number 0, naturally we start counting from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then if you include the number 0, then you have sets of number called the natural numbers. So if we include 0, if we start from 0, you have what we call the set of numbers that we call the natural numbers. So when we say natural numbers, it's actually starting from 0. Okay, 0, 1, 2, 3, 4, like that, till infinity, till as many as you can, till infinity. So this is called natural numbers. So when you hear natural numbers, we're talking about 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, as much as you can, as much as you can. So this is called the natural counting numbers. Okay, let's go to the next one in numbers, which is called the integers. Integers are whole numbers. Integers are whole numbers, meaning no fraction, no decimal. No fraction, no decimal. And we have two types of integers. We have the positive integers and we have the negative integers. So when we say integers, as long as the number is not a decimal, is not a fraction, there is an integer. Okay, as long as the number is not a decimal, you are not saying 2 point. If I write 2.5, this is not an integer. If I write 2.5, this is not an integer. Integers are whole number, like 2, like 4, like 5, like 7. Any whole number is an integer. But integers are divided into 2. Like we said, integers are into 2. We have the positive and the negative integer. We have the positive and the negative integer. So integers are into 2 groups. We have positive and negative integers. Positive numbers we know already, like 1, 2, 3, 4, 5, 6. Okay, positive I'll write plus like this. I'll write positive like this. Okay, and then negative integers are -1, -2, -3, -4, -5. Like temperature. During winters we have temperatures as low as -5, -10, All the negative numbers are called negative integers. Negative whole numbers are called negative integers. Okay, so that's for integers. Now we move to, you can see these are the negative integers. We have -3, -2, -1. These are integers. Then you have 0, because 0 is part of the natural counting number. Then you have 1, you have 2. These are called the positive. So this way they are called the positive integers. This way we call them the positive integers. And this way we call them the negative integers. We call them the negative integers. Okay, so that's that for integers. Now we move to rational numbers. Rational numbers are numbers which can be expressed as fractions. Numbers which can be expressed as fractions. Most of the time, numbers that you can express as fractions, you can also express them as decimal. So rational numbers are numbers which can be expressed as fractions. And numbers which can be expressed as rational numbers are numbers which can be expressed as fractions, okay? Now we can begin to take a look at them. We say numbers that can be expressed as fractions. Let's begin to take a look at them. It includes whole numbers. Whole numbers are also fraction. Can also be expressed as fraction. Whole numbers can also be expressed as fraction. How? If I write 2, 2 means 2 means 2 over 1. If I write 2, so I'm just trying to show you how 2 can be written in fractional form. It means 2 over 1. If you want to put it in fractional form, it becomes 2 over 1. Okay? It becomes 2 over 1. Okay? So that's that for that. Now, it includes whole number. Rational number includes whole number. It includes fractions. Okay? Rational numbers includes whole numbers. It includes fractions. Okay? It includes terminating decimals. Decimal that can terminate. What we mean by terminating decimal, like 0.625. Okay? Terminates. It ends. Okay? Terminating decimal. There, another type of rational number is recurring decimal. We have recurring decimal and terminating decimal. These two decimals are rational numbers. They are rational numbers. Any decimal that terminates is a rational number. And any decimal that is recurring, like 0.333333 is a rational number. Recurring decimal is a rational number. So we give you a list of questions and you go to 10. Okay, recurring decimal. This and this for decimal, recurring decimal. So if you have a recurring decimal or terminating decimal, they are called rational numbers. They are called rational numbers. They are called rational numbers. For example, 0.2 is a terminating decimal, it's just 0.2. In fractional form, is 1 over 5. So this number is a rational number. This is rational number. This is rational number. So I put arrow on top of it. This is a rational number. A number that terminates is a rational number. A decimal that terminates is a rational number. Okay, like 0.3 is a rational number. In fractional form is 3 over 10. If you change it to fraction, it's 3 over 10. 7 as a whole number is 7 over 1. Like I already explained this one. Whole numbers can also be expressed as fraction. 1.35 is a rational number. All these are rational numbers. So if I put arrow, it means irrational. We've not come to irrational. So this in fractional form, this is 153 over 100. Then 0.2, what it means is 0. You see they put dot on the 2. So it means 0.22222. Like it continues, say it's a recurring decimal, 0.2222. That's why we just write 0.2 and put dot on top. That's why we just write 0. And put dot on top. In fractional form is 2 over 9. In fractional form is 2 over 9. So all these are, because it's a recurring decimal, it's also a rational number. It's also a rational number. Okay? So whether it's a recurring decimal, or it's a terminating decimal, or it's a fraction, or it's whole number, they are all categorized or classified as rational number. Now let's move to irrational numbers. Irrational number, on the other hand, is the opposite. Okay? If you say irrational number, are numbers which cannot be expressed as fractions. They are numbers which cannot be irrational, double R. Irrational numbers are numbers which cannot be expressed as fractions. They are numbers which cannot be expressed as fractions. Now let's give an example of irrational number. Square root of numbers other than square numbers. You know, if you square square number, you get rational numbers. 60 is a square number. Okay, we're going to talk about square numbers later on. 60 is a square number. So the square root of 60 is 4, which means root 60 is a rational number, which means this is a rational. This is what? This is a rational number. Now, for irrational, the example I'm making here is that the square root of number other than square number, for example, root 5. Root 5, this is irrational. This is what? Irrational. So I write I arrow. This is irrational number because square root of number other than square number. Square root of any number other than square number. Only square number you get rational. If you put root on any other number, 9 is a square number. If I ask you, is root 9 rational or irrational? It's rational because you can find the square root of 9 and it gives you 3. So it's a rational number. But what I say root 10, 10 is not a square number. So root 10 will be what? Irrational number. Will be irrational number. So the point here is square root of other numbers other than square numbers. Square root of numbers other than square number. Then another irrational is pi. This mathematical factor, pi, is an irrational number. Is an irrational number. Okay, so these are examples of irrational number. The root of numbers other than square number, like root 2, is irrational number. Root 2 is irrational number. Okay, and if you ask to define irrational numbers, you say irrational numbers are numbers which cannot be expressed as fractions. They are numbers which cannot be expressed as fractions. Now we go to real numbers. Now real numbers are numbers, sets of rational and irrational numbers put together. They are called real numbers. So if you have real numbers, if you're talking about real numbers, you're saying a set of rational and irrational. So if I'm talking about real number, it's made up of two parts. If I'm talking about real numbers, it's made up of two parts, meaning my rational numbers that I've talked about and my irrational number. If you put them together as one set of numbers, then those numbers becomes real numbers. Set of rational numbers and irrational numbers are called real numbers. They're called real numbers. Is that okay? A set showing both rational numbers, showing both irrational number. Those set of numbers are called real numbers. They are called what? Real numbers. Okay? So now we go to prime numbers. Let's go to prime numbers. Prime numbers are numbers which has only two factors, itself and 1. Numbers which can only be divided by itself and 1. They are called prime numbers. Okay? Prime numbers are numbers that only has two factors. Itself, that number itself, and 1. It has 1 and itself. What do I mean by itself? For example, if I say 2. Okay, if I say 2. 2 is a prime number. Why? Because 2 has only two factors. Okay? Prime numbers. 2 has only two factors. What are the two factors? 1 and 2. Okay? Okay, 3. And 2 is the only even number that is a prime number. 2 is the only even number that is a prime number. Every other prime number falls in the odd number category. Every other prime number falls in the odd number category. So when they ask you what is prime numbers, you say numbers prime numbers are numbers which can only be divided by itself and 1. Which can only be divided by itself and 1. Or you can say is the numbers which has only two factors, itself and 1. Okay? So prime numbers, if we are to list them with Pn, prime numbers. If we are to list them, we say 2 is a prime number, 3 is a prime number, 4 is not, 5 is a prime number, 7 is a prime number. Not all odd number. Before you start mentioning all odd numbers. 9 is an odd number, it's not a prime number because 9 has a factor of 3. 3 can divide 9. So 9 is not only divided by itself and 1. So 9 is not. So the next one is 11. In the 11, 13. The next one, 50 is not because 55 can divide it and 3 can divide it. The next one is 17. The next one is 19. The next one is 19. The next one is 21 is not because 3 can divide 21, 7 can divide 21. The next one is 23. The next one is 27 is not, 25 is not. The next one is 29. The next one is 31. The next one is 31. 33 is not. Why? Because 3 can divide 33, 11 can divide 33, and 33. So it has multiple factors. 35 is not. 37 is the next one. 39 is not because 3 can go into 39. 41, the next one is 41. The next one is 41, and so on and so forth. 45 is not. 43, the next one is 43. After 43, we have 47. Then we have 47. Okay, because you need to know the prime numbers from 1 to 100. The next one is 47. The next one is 51 is not. 49 is not. 49 you can find the square root. Square root is 7. 7 times 7 is 49. 49 is not. 53, yes. Next one is 53. Well, 51, no. 51 can be divided by 3. You know, rule of divisibility by 3. Rule of divisibility by 3 is that you add the numbers together. If you say 51, you say 5 plus 1, 6. If 3 can divide 6, it means 3 can divide 51. So 51 is not. Now we go to 55 is not. 5 can go into 55. 11 can go into 55. Okay, 50. What of 57? 57, if you add them together, you get 12. 3 can divide 12, so 3 can divide 57. So 57 is not. You have, well, 59, probably. 59, okay. 61. Yes, 61, like that. Okay, so I think we should be able to complete it to 100, okay? So we should write the prime numbers on our own from 1 to 100. You should be able to see. In most tests, they ask you to write prime numbers 1 to 100. Now, we go to the next one, we go to reciprocal. What's reciprocal? Reciprocals are the inverse of a number. If I ask you to find the reciprocal of 2, if I give you 2, okay, if I give you 2, I say find the reciprocal of 2, it means 1 over 2. If you want to find the reciprocal of any number, just say 1 over that number. So this is easy peasy. We move on. If I ask you to find the reciprocal of 100, you just say 1 all over 100. That's the reciprocal of 100. So reciprocal of a number is the inverse of the number. Means 1 over that number. It means 1 over that number. So that's it for reciprocal. It's not a big deal. So we'll move on. They give you, okay, the big deal is, what if they say, what is the reciprocal of a fraction? They give you 7 over 12. They give you 7 over 12 as a fraction. They ask you, what's the reciprocal of 7 over 12? So what do? You just say 1 over 7 over 12. 1 over 7 over 12. When you do this, this will flip. The original fraction will flip. It will become 12 over 7. It will become 12 over 7. So when they give you the reciprocal of a fraction, it only simply means that you should flip the fraction. You should flip the fraction. Is that okay? This will become 7 over 12. Because if you say 1 divided by 7 over 12, it becomes 1 times 12 over 7, and then you get 12 over 7. Is that okay? So that's that for this one. Now let's move on quickly. Let's move on. The next one after reciprocal is square numbers. Now let's talk about square number a little bit. We need to itemize some square numbers, and then we will move to cube numbers, and so on and so forth. Now let's move to square numbers. Square numbers. Okay, let's itemize square numbers. Let's itemize square numbers. Let's itemize square numbers quickly. Let's itemize square numbers. Okay, if I have 1, square numbers means square the 1, 2, 3 you've learned. So if I have 1 square, 2 square, so the answer, the result of this squaring your natural counting number, 3 square, okay, 4 square. I'm going to write the numbers out that are called square number. Okay, 5 square, 5 square, 6 square, 7 square, 8 square. So let's just do 1 to 10. 8 square, 9 square, 10 square. Now let's write them out. So the numbers that we call square numbers. Okay? You know, when you square 1, you get 1. So 1 is a square number. When you square 1, you get 1. When you square 2, you get 4. So 4 is a square number. When you square 3, you get 9. 9 is a square number. When you square 4, you get 60. 60 is a square number. When you square 5, you get 25. 25 is a square number. When you square 6, you get 36. 36 is a square number. When you square 7, you get 49. 49 is a square number. When you square 8, you get 64. 64 is a square number. When you square 9, you get 81. 81 is a square number. When you square 10, you get 100. 100 is a square number. So be familiar, at least the first 1 to 10, you should know that. 1 is a square number, 4 is a square number, 9 is a square number, 60 is a square number, 25, 36, and so on and so forth. So these are called square numbers. So we move on. Just multiply the number by itself. 1 square means 1 times 1. You remember, right? 2 square means 2 times 2, which gives us 4. When you say 2 square, you are actually saying 2 times 2, which gives us this 4, which gives us this 4. 3 square means 3 times 3. Multiply the number by itself. That's the meaning of square number. Is that okay? Now we go to the next one, which is called the cube numbers. So this has similitude with what I just explained. This has a similitude with what I just talked about. Now for cube numbers, we are going to raise the number to power 3. For cube numbers, we raise the power. For square number, we raise the power to 2. For cube numbers, we raise the power to 3. We raise the power to 3. So for cube numbers, we raise the power to 3. Okay? Raise the power to 3. Meaning 1 to power 3, 2 to power 3, 3 to power 3. We're going to write the numbers out. 4 to power 3, 4 to power 3, 5 to power 3, 6 to power 3, 6 to power of 3, 7 to power of 3, 8 to power of 3, 9 to power of 3, and 10 to power of 3. So 1 to power 3 is 1, and 1 to any power is 1. 2 to the power 3 is 8. It means 2 times 2 times 2. You multiply 2 3 times. It doesn't mean 2 times 3. So student will say 6. No, you fail. Okay? Here, 3 to the power 3 is 27. 3 to the power 3 is 27. It means 3 times 3, that's 9, times another 3, which is 27. So this is 27. 4 to the power 3, you get 64. It means 4 times 4 times 4 in 3 places. You get 64. 5 to the power 3, it means 5 times 5 times 5 in 3 places. You get 125. You get 125. 6 to the power 3, you get 216. 6 times 6 times 6, you get 216. 7 to the power 3, you get 343. That's 7 times 7 times 7. 7 in 3 places. 8 to the power 3, we get 512. That's 8 times 8 times another 8. You get 512. 9 to the power 3, you get 729. 729. That's 9 times 9 times another 9. 10 to the power 3, you get 1000. 10 to the power of 3, you get what? 1000. You get 1000. Okay, so these numbers are called cube numbers. These numbers are called cube numbers. These numbers are called cube numbers. Now we go to factors. We go to factors. We go to factors. Now what are factors? What are factors? Let's take a look at factors. The factors are numbers that can divide a particular numbers. All the numbers that can go into a particular numbers. All the numbers. For example, we start with 12. Let's say we write 12. What are the numbers that can go into 12? Let's list them out. 12 can be divided by 1. We start with the smallest. 12 can be divided by 2. So 2 is a factor of 12. Any number that can divide a number, they are factors of that number. 3 can divide 12, we write 3. 4 can divide 12, we write 4. 5 cannot divide 12, we don't write it. 6 can divide 12. So once you reach the half of the number, once you reach the middle of the number, the next one is the number itself. The last one is the number itself. 12 is a factor of 12 because 12 can be divided by 12. 12 divided by 12, you get 1. Okay, so these are called factors. Not all numbers that can divide a particular number, they are called the factors of the number. They are called the factors of the number. So another way to list them is I write 12 like this, and then I begin to write 1 times 12 equal to 12. 1 times 12 equals to 12. 2 times 6 equal to 12. 3 times 4 equal to 12. So you can see, then I can begin to list them like this. Okay, this becomes our factors. We can list them 1, 2, 3, 4, 6, and 12. They become the factors of 12. Okay, that's that for that. So any number, we are not talking about prime factor first. When we talk about prime factor, we will explain that. But factors are all numbers that can divide a particular number. So if you are asked for factor of 36, all numbers that can go into 36, like 1, like 2 can go into 36, 3 can go into 36, 4 can go into 36, 5 cannot, 6 can go into 36, 8 cannot, 7 cannot, 8 cannot, 9 can go, you write down 9, 12 can go, you write down 12, 80 can go, which is the middle, you write 80, after 80 is 36 itself. So these are called factors of 12. Now let's talk about prime factor, the very important one, the prime factors. So after factor, we talk about prime factors. So what is prime factors? Let's talk about prime factor. Now let's talk about prime factors. It's a little bit different from the factor itself, okay? Factor will just list all the numbers that can go into that particular number. But when you say prime factors, they are the prime numbers of all the numbers that can go into that particular number. They are the prime numbers of all the numbers that can go into that number. Now, out of all the numbers we listed, out of all the numbers we listed just now, the only prime factors will be 2 and 3 because they are the prime numbers. 2 and 3 are the prime numbers in all the factors of 12. 1 is not a prime number. You know why? Because a prime number must have itself and 1 as factor. 1 has 1 and 1. 1 and 1 is 1. So 1 is not a prime number. 2 is a prime number. 3 is a prime number. 4 is not. 6 is not. 12 is not. So for prime number for 12 is only 2 and 3. If you've been asked to give the prime number, is only 2 and 3. So if you write 12, they say give the prime factors of 12. You can see it's different now. It's different from the previous one. When they ask you for factors, you give all. When they ask you for prime factor, you give only. Another way to do it, if you're giving 12, you want the prime factor, you just divide 12. What number? 2 going to 12, you get 6. 2 going to 6, you get 3. 3 going to 3, you get 1. You write out the prime factorization. 2 times 2. Write out the prime factorization. 2 times 2 times 3. 2 times 2 times 3. So what this means is that even though 2 repeats itself, 2 times 2 means 2 raised to power 2, right? Times 3. Since 3 occur only one time, you say 3 to the power of 1. So the 2 prime are what? The 2 prime are what? The 2 prime are 2 and 3 only. The 2 prime numbers are 2 and 3 only. These two, the 2 prime factors are only 2 and 3 only. Okay? So they are the only 2 prime. So you can break a number down. If a number repeats itself, even though 3 times, it's just same as that same number. And then this. So the only prime factors are 2 and 3 only from this case scenario. So I hope that is clear. Now, examples, there are questions that come to say, find the prime factors of 18 and express it as a product of prime numbers. So if you are asked to find, it's just what we did just now, 18, you go to divide it. You break it down. You break 18 down. 2 go into 18, you get 9. So 2 cannot go into 9. 3 go into 9, you get 3. Right? 3 go into 9, you get 3. Then 3 divide by itself, or 3 divided by 3, you get 1. You get 1. So what are the prime numbers? Because the question says find the 5 factors. So let's write it out. The prime factors are 2 times 3 times, prime factorization is 2 times 3 times 3. But the prime numbers are only 2 and 3. Because 3 repeats itself, you just measure it once. Okay? But if you want to put it in the product of its prime number, we put it like this. If you want to put it in the power form, you say 2 times 3 to the power of 2. Because 3 occur twice, you say 3 to the power of 2. 2 occur once, if you like, you can put 1 on top here, or you don't even put it. Okay? So the 2 prime factors and 2 and 3. Only these 2 and these 3 are the prime factors. Okay, so that's that for that question. Now let's go to, we've already explained prime, rational and irrational numbers. I have already told you rational numbers are whole numbers, fraction, recurring decimal, terminating decimal. Irrational numbers are square root of numbers other than square number and pi. So we've done this, no need to repeat this aspect. We move on. So more example of prime number 24. Find the prime factors of 24. I express it as a product of its prime number. You break 24 down. 2 into 24 you get 12. 2 into 12 you get 6. 2 into 6 you get 3. 3 into 3 you get 1. So you bring these ones out. You bring all this one out as your prime factors. And the numbers are only 2 and 3. 2 occur 3 times and 3 once. So the prime numbers are 2 and 3 only. So if you give you 75, you divide 75. 3 go to 75, you get 25. 5 into 25, you get 5. 5 into 5. So you get what? You get 3 times. For 75, you get 3 times 5 times 5. You get 3 times 5 times 5. You get 3 times 5 times 5. So this is the product of its prime numbers. So which you can rewrite like this, 3 times 5 squared. You can rewrite like this, 3 times 5. Because 5 occur twice, you write 3 times 5 squared. So the prime numbers are what? The prime factors are only 3 and 5. Are only 3 and 5. These are the prime factors, 3 and 5 only. They are the prime factors. Okay, that's that for that. Now let's go to what we call the highest common factor, HCF. Let's go to what you call the highest common factor. HCF. Okay? ACF is the highest factor that is common to two numbers or three numbers or four numbers, depending on the number of numbers they give it to you. For example, we want to give you two numbers. Let's do the ACF of these two numbers, 12 and 18. ACF, highest common factor. So we're going to find the factor that is common to 12, find the highest common factor of 12 and 18. 12 and 18. So what you do, you bring out the product of their prime factors. So you break down 12. 12 we already know is 2 times 2, 2 times 2 times 3, because it's 4 times 3. But you must not write 4 times 3. You break it to the prime numbers, okay? 2 times 2 times 3. If you don't know, you do like this, like we were doing just now. You break 12 down. You say 2 go into 12, you get 6. Now 2 go into 6, you get 3. Now 3 go into 3, you get 1, right? Then you write this, you multiply this number out. Write them out like this. Okay, you do same to 18. You break 18 down like we did just now, and the product we got is what? For 18, if you do for 18, you get 2 go into 18, you get 9. So 2 cannot go into 9. 3 will there go into 9. So you say 3 go into 9. 3 go into 9, you get 3. Then 3 go into 3, you get 1. 3 go into 3, you get 1. So for 18, you get 2 times 3, 2 times 3 times another 3 for ACF. 2 times 3 times another 3. Now what you do is to find what is common, what is the same. Okay, it's for us to find what is common factor. So 2 is here, 2 is here. We're going to take it. In finding the ACF, you now have to bring coincidence or intersect, like where you have the number here and here. Even if it's diagonal like this, as long as the number appears here and appears here, you can do a diagonal collection. Okay, so these 2 here, you write it one time. There's 2 here, there's no 2 here, so I ignore. So I say multiply by, there's 3 here, there's 3 here, so I take. So I say times 3. So my ACF is 2 times 3. The ACF is 2 times 3, which is 6. So the highest factor that can divide 12 and 18 is 6. 6 is the number. What is the meaning of ACF? Is that number that can go into 12 and 18 without a remainder. The highest number. 3 can do the same thing. 3 can divide 12, 3 can divide 18, right? 2 can go to 12, 2 can go into 18. But the highest one is 6. After 6, there's no single number that can divide both numbers. 6 can go here. 12 divided by 6, you get 2. 18 divided by 6, you get 3. After that, there's no number. 9 cannot divide both. 9 can only divide this, cannot divide this. Okay? 12 cannot divide both, 18 cannot divide both. So the highest number, the highest factor that can divide a 2 given number or 3 given numbers, depending on how many numbers they've given you to find, that highest number that can go into them, highest factor that can go into them, is called the ACF. Is that okay? So we're done with ACF. Even if I give you 3 numbers, except you want us to do one more. Let's say I give you 18. I say find the ACF of 18, 24, and 36. 18, 24, and 36. If you give you that 18, 24, and 36, you are asked to find the ACF. Then this is what you do. You break each one down. We already know for 18 is 2 times 3. 2 times 3 times 3, right? 2 times 3 times 3 times 3. Okay, for 24, you remember 24 is 8 times 3, right? So you can say 8 is 2 times 2 times 2. So you always start from the smallest one. 2 times 2 times 2 times 2. Then before we say times 3, right? Because 8 times 3. Then for 36, 36 is 9 times 4. So 4 is 2 times 2. So I write 2 times 2. 4 is 2 times 2. And then 9 is 3 times 3. So I write 3 times 3. This will give us 36. So HCF, let's change the color. HCF is equal to, you look, 2 appears here, 2 is here, is here, is here. All 3 places you have 2, so you write it one time. Here there's 2, there's no 2 anywhere here. Even if the 2 was here, I could have still be able to take it like this. But there's no 2 anymore in 18. So we discard this one. There's 3 here, there's 3 here, there's 3 here. So I can easily take this 3. Okay, I can easily take this 3. There's 3 here, there's no more 3 here, and there's, even though there's another 3 here, there's no more 3 in this one. So that's it. So the only factor is that 2 times 3. So the HCF is 2 times 3. 2 times 3, which is equals to 6. HCF is 2 times 3, which is equal to 6. So 6 is the highest factor that can go into 18, 24, and 36. 6 is the highest factor that can go into it. It doesn't mean all HCF, the answer will be 6, okay? It's just that coincidentally, the 2 examples I have given you, we landed as answer 6. Now let's move on quickly to the next one. Multiples. Let's go to multiples. Multiples are just you multiply the numbers. For example, if I say find the multiples of 5, you say 5 times 1, 5. So 5 is a multiple of 5. 5 times 2, 10. 10 is a multiple of 5. 5 times 3, 15. 15 is a multiple of 5. 5 times 4, 20. 20 is a multiple of 5. 5 times 5, 25. 25 is a multiple of 5. So multiples are you just multiply that number by 1, 2, 3 by a natural counting number. 5 times 6 is 30. So 30 is a multiple of 5. And it continues. It goes on and on and on and on like that. Is that okay? So now let's treat what we call the lowest common multiple. If you are given 2 numbers or 2 factors, 2 numbers, sometimes you are asked to find the lowest common multiple. For example, if we are asked to find the LCM, lowest common multiple is called the LCM. Let me write LCM of 2 numbers or 3 numbers. You are asked to find, let's start with a simple number, 5 and 15. You are asked to find the LCM of 5 and 15. LCM of 5 and 15. We are giving the LCM of 5 and 15. So we write the factors of 5. 1 times 5 is 5. 1 times 5 is 5. 50 is 50. You can, if you like, because this will start from 1, you can also start from 1. So you can say 1 times 3, but it doesn't really matter. 1 times 3 times 5. 1 times 3 times 5. Now the LCM will be all factors that, okay, LCM is not going to be like HCF. You know, for LCM, for HCF, we start to bracket. We start to bracket like this. We start to bracket like this for HCF. But for LCM, we take the number where it occurs the most. Okay, we take the number where it occurs the most. 1 appears here once, and also here once. So we just take it once. If it appears here twice, we take it where it occurs the most. Now, 3 only 1 time. So I write 3. And then 5, 1 here, 1 here. If 5 was 2 times here, I only take the 1 2 times here. I will ignore the 1 here. So, but unfortunately here it occurs only once in both scenarios. So our LCM will be 15. 15 is the lowest number that 5, lowest multiple of 5 and 15. 15 is the lowest. 30 is also a multiple of 5 and 50. 60 is a multiple of 5 and 50, but 50 is the lowest one that 5 and 50 can go into. Is that okay? 50 is the lowest one. Meaning the next one will be 50 plus 15, which is 30. The next one will be 45. The next one will be 60. You keep adding 15 to it. Okay? You get, but the lowest one, because they're asking for the lowest one, the lowest multiple, LCM, lowest multiple of 2 numbers, 50 is the lowest one. Another way to do it is you write 5 which is, I think, to some students is the easiest way. Okay, you write 5 and 15 like this, and you divide both of them concurrently, simultaneously. Divide both of them simultaneously. You say, what can go here? 3 can go, right? So I start with 3. So 3 can go, but 3 cannot go into 5. So I bring 5 down because it cannot be divided by 3. But 50 can be divided by 3. Alright? 50 divided by 3, I write 5. I write 5 here. Then the next step you see is that 5 can now be divided by 5. So this 5 divided by this 5, I get 1. This 5 divided by this 5, I get another 1. So you multiply this, you get the LCM. You just multiply what is here, you get the LCM. So LCM, this method proves to be easier and more convenient. LCM is equals to 3 times 5. 3 times 5, which is 15. LCM equal to 3 times 5, which is 15. Okay, now let's move on to... So all you need to do to master them is to solve a lot of questions regarding all of this. Now we go to square roots. Let's talk a little bit about square. I only talk about square numbers. So it's like the opposite of square numbers. Let's talk about square root and cube root briefly before we end this chapter. Square root. Square root. Okay. The symbol for square root is like this. You write something like this. This is the symbol. For example, if I say find the square root of 16, I'm asking you to tell me the number you multiplied twice that gave you 16. I'm asking you to tell me the number that you multiplied twice that gave you 16. What number did you multiply twice that gave you 16? So that number is what? 4. It was 4 plus or minus 4. It was 4, we multiplied 2 times, that gave us 16, right? It was 4, we multiplied twice, that gave us 16. So it's actually plus minus 4. You know why? Because if you say minus 4 times minus 4 times minus 4, it will give you 16, positive 16. To give you positive 16. So if you say 4, which is plus 4, times 4, in ordinary form is plus 4. It will also give you 16. So our answer is usually plus minus. When you find square root, but even though most of the time we don't write it, but that's what it is. Even if we don't write, we just write 4. We don't write plus 4 minus 4, but the answer is actually plus 4 and negative 4. So all square number that we studied before, we can find their square root, like 25, root 25. So if we give you root 25, we say find the square root of root 25. The answer will be plus minus 5. But normally I just write 5 for simplicity. Okay, if I ask you for the square root of 49, if I ask you for 49, is 7. If I ask you for 49, it's 7. Is that okay? It's 7. Now we move on to, in case they ask you for fraction, they say the square root of 1 over 9. It's not a big deal. Square root of 1 is 1. So you just say this 1 over 3. You put the square root here separate. You put the square root here separate. That's the next step. Okay? And then square root of 1 is 1. And square root of 9 is 3. So your answer will be 1 all over 3. So don't get scared if they give you fraction. Like this one, they ask you square root of 9 over 100. They give you 9 over 100. It's not a big deal. What it means is that you just say, what's the root of 9? You get 3. What's the root of 100? You get 10. So your answer is 3 over 10. So it's not a big deal. 3 over 10. Is that okay? So it's not a big deal if they give you fraction or whatever. Okay, we move on. Now we go to directed numbers. Let's go to directed numbers. Directed numbers here we talk about, we use it for temperature. This one always in paper 2. The first questions usually in paper 2 is from directed numbers. The first question in paper 2 in IGCSE is usually from directed numbers. A negative temperature, negative and positive. Okay, they just give you, they want you to add, do it and see whether you know how to do this. Okay, so here we use plus minus. For example, if I tell you temperature in a place is -3 and there plus another temperature which is 8, what is it? What is it? The answer is 5, but I can show you with the directed numbers. So this is 5 degree. Okay, the temperature will be 5 degree. Now how? Let's say I have a number line. I have here 0. I have -1, -2, -3, -4, -5. Okay, and let's have the positive one. We have 1, 2, 3, 4, 5, 6. Okay, so we can draw lines to reach each number. Okay, to save time, I think we already understand that you're drawing line to each. Okay, so now if you have this, the question says -3 plus 8. Okay, when you go to a directed number, you start with the first sign. So when they say -3, we got to go to -3. We got to go to -3. Come here, -3, that's where you start from. When they say the next sign, if it's plus, you go to the right, you count to the right. If it's minus here, you count to the left. This sign, whatever sign here is, that is this second sign, whatever is here is to tell you which direction to go. So this sign, -3, is to tell you the number to start from. You are starting from -3. Okay? If here is plus, I'll count to the right. I'll count 8 times. 1, 2, 3, 4, 5, 6, 7, 8. So I stop at 8 because plus 8. So the number I will find at that point is 5. So that's why my answer was 5. That's why my answer is 5. Using directed number, this is how we operate. This is how we use it to solve numbers. Okay? So all you need to do is to solve some example here. So here with this we come to the end of today's class. There are some questions for you to exhaustivate. So thank you for joining us.